Yeah, so we've been talking about the basics of Python, where we said that it is actually one of the most popular programming languages that is used in data science and data analytics projects. So far, so good. We had our outline. Let me just open our outline. So I think our outline was here. And we said earlier that for us to effectively understand programming, and I think I should log it. Sorry for that one. Perfect. So I was talking about the building blocks of programming, and this is actually one of the easiest way you can actually understand a programming language. So we normally start with defining what are variables and also providing guidelines for naming a variable. So always keep in mind that a variable is just a symbolic name that we use to assign data. So that is what we mentioned, and it is the first building block in programming. Then from there, we've mentioned, and this one took us a lot of time, to actually explore different types of data that we can interact with in our programming. So we mentioned data like integers, we mentioned floats, we mentioned strings, we mentioned booleans. We even went ahead further and mentioned the sequence data types like a list, we mentioned tuples, we did dictionaries, we talked about sets. So they're equally important. It's actually equally important to understand the various types of data you can work with in your programming. Okay. Now from there, we did conditional statements, and we saw that conditional statements are actually the basis of decision-making in your program. So you're going to notice that at some point, as you write your programs, you need to make a decision, okay? These decisions are actually based on whether a condition evaluates to true or a condition evaluates to false, what we called the Boolean logic. Okay, so that was equally important, and we are going to use it when you want to run decisions in our program. Now, yesterday, we talked about looping statements. And we saw that it is very, very important to understand looping so that you are able to repeat a code execution until a certain condition is met. This is very, very important. We did it, and we said that mainly in Python, we have the two types of loop, which is actually the while loops and the for loops. And now today, I have already prepared a program where now we want to talk about Python functions, and at some point you're going to refer to what are modules. So in case there is any lesson you have missed concerning looping, conditions, data types, variables, so you can always follow us through our Jenga e-learning platform. So far so good. We have 10 videos. I'm just refreshing it. Sorry, taking a while. So yes, we have 10 videos, and these videos actually is every lesson that we've ever had in this program, starting from orientation. Maybe you want to understand the introductory part of this course. You want to understand now clearly what are variables, what are the numerical data types, what are the string data types, how can you work with a loop, not a loop, sorry, but a list data type, how can we interact with sets and tuples, what about dictionaries, how about you talk about Booleans and how do you create conditional statements in your program? And also yesterday, if you want to understand how to run Python loops, I think all these videos are uploaded on our YouTube channel. Similarly, you can also find them on our e-learning portal. So with that one, allow me today, we talk about functions. Let's talk about functions here. So what I want us to do, I think we'll close all these tabs. Let's close. Let me just, sorry. Yes, maybe yes. Then from there, I want us to set up our environment. The first thing we've been doing, as usual, is that we need to open the notes. so that we are going to first to understand what are Python functions, what are their characteristics, types of functions, and so on and so forth. So it's actually the notes that you want to use. So make sure you've opened them on the e-learning portal. Then from there, I also want you to open up this notebook on a new tab. So just copy this notebook here. Just copy this notebook here on a new tab. So you can just press Control-C, and then you open a new tab here. Then you have Control-V, then you press Enter. So you open it on a new tab, that one. So this actually will act as the guide on us to understand Python functions. So you want to understand them, you want to do some practices. And now for you to do your own practices, like I've been advising all the time, I want you to open a new notebook here. So I want you to call it, so let me just open a new notebook here, Google Colab, that one. Then create a new notebook that we will call Python function class practices in our morning sessions. So let's do that one. So open up a new Google Colab as usual. And this is actually the best way you can learn. So you can actually learn by doing the practices, okay? That is actually the way to go. So let's label this notebook Python functions. So now we're talking about functions. And this is actually our class practice. So it's important to do the practices. And this one, I will call it for the morning session. So I'm really apologizing for our evening classes. We're having challenges, but I think from now on, we have already rectified now everything. So label the notebook Python functions. This is our class practice, and this is for the morning session. Please always remember that the extension must be there. So it should be .interactive Python notebook. So if you're ready to go, I'm okay. I'm also ready to start. So we are going to start by now going to the notes. Theoretically, we try and first understand what are Python functions, what are their characteristics, and how do you define them in your program. So let's go there. I hope you're there. In case you don't have maybe this link, probably I could also share with you on our chat. So in case you don't have that one, it's good to have it so that now we can follow through together. So with that one now, let's now start with what are Python functions? So let's start from there. What are Python functions? So I'll start from here, yes. Python functions, I think they are very important. So by definition, we can say that functions in Python are basically reusable blocks of code that is actually designed to perform a specific task. So let's say you are a data scientist and you want to perform a reusable specific task in your program, then definitely you will need to find it in a function. So let me even give you a good example. At some point, you might want to clean data, or you want to transform data, or you want to read data from Excel. Okay, so all these reusable tasks that you need to perform, they are actually defined in a function. So what we are going to notice in instruction is that they actually improve the code organization. They also make our code more readable. They make our codes reusable, and this will also reduce redundancies that we have in our program. So let's talk about the characteristics of a function. So these are actually the main characteristics of a function in any programming language. So number one is that if you define a function, then you are going to enhance what we call code reusability. So this one means that functions allow for repetitive use of block of code without rewriting it. That is what we're going to see. We can actually reuse a code without rewriting it, so long as we define a function and then we have the function calls. Okay. Another characteristic of a function is that functions are actually providing what we call modularity. So this means that with a function, you can actually break down a very complex problem into smaller, manageable parts. So if I want to even give a good demonstration, let's say you have a complex task of creating an M-Pesa application. So M-Pesa application looks complex, but for us to work with it in a more manageable manner, we can actually break it down into several functions. For example, we can have a function to send money. We can have a function to withdraw cash. We can have another function to check your balance. We can have a function to change your PIN. So now you're realizing that the complex task of building the M-Pesa application is now broken down into smaller, manageable parts that we can handle in different teams. And there's a team that will be assigned the send money module. There is another team that will be assigned the withdraw cash module, so on and so forth. So that's actually what we call modularity. Another important aspect about function that you're going to see is that functions have a property we call encapsulation. So encapsulation suggests that we can actually hide the implementation details and provide a clean interface. So this is something you're going to notice, especially in our data science application. I want to give you a good example. You have a task to do machine learning. You're trying to think about, how do I make a machine to learn? So that implementation detail can be done and hidden for you. So you just have to call a function, and then the function will actually allow the machine to learn without even you understanding how that one was implemented. A good example, if you put a function like scikit-learn have some functions that will allow your machine to learn from data. So that is what we call encapsulation, whereby we hide the implementation details. So at some point, this is very important, we are going to see that functions have what we call parameters and arguments, okay? So this will allow functions to accept inputs that we call parameters and operate on them, then return to us some outputs. So some function requires some input, okay? A good example, if you create a send money function, then it will require to provide the sender and the amount. So those inputs that you feed into a function are what we call parameters. So they're equally important as we build some functions. And then finally, we are going to notice about the return statement. And it is actually a policy that every time you define a function, it must return a value. So if it doesn't return a value, then that one means that the function doesn't have an output. I want you to imagine you're giving some inputs and then you're not getting some outputs. So by definition, you can actually say that a function must have a return statement. If you don't specify the return statement, then the function returns what we call none or zero, okay? So that is something we are going to elaborate as we define our functions. So I hope this one makes sense, that there is code reusability, we have modularity, we're going to talk about encapsulation, we're doing some parameters and arguments, and then very importantly, we are going to add return statements into our functions. So moving further, we are going to notice that there are several functions in our program. And so far, so good, we've been interacting with them without even knowing, okay? So the first type of a function that I think every one of us here already have interacted with are what we call the built-in functions, okay? Built-in functions. So if you want to define the Python built-in function, then you're going to notice that you don't have to build them. They already come with the Python compiler, okay? So they provide several built-in functions. Like a good example is the print function. It's a built-in function because its specific task is to display data back to the user. And we can actually reuse it anytime we want. So long as you want to display data in a program, we'll be always calling the print function. So print function is actually one of the built-in function in programming. Another one is what we call the len function. We've been using this function anytime you want to return the number of items in a sequence data type. For example, I want to return how many characters I have in a string, or how many items I have in a list or a dictionary. Then we've been using the len function, and we saw that its specific task is to return the number of items in a sequence data type. We have the sum function, we have the type. I think we've been using this one for some time now. If we want to define the data type that we've stored in a variable. So we've also had the range function as we were doing the loop whenever we want to generate a list of numbers. So these are what we call the built-in functions. And I hope you can see they have similarities. Let's even notice their similarity. Number one, any function name must start with a lowercase. I hope you're noticing that one. Any function name must always start with a lowercase, like the print, the length, the sum. Like anytime you define a function, you must start with a lowercase, okay? Number two is that any function we have must have a parenthesis to the end. I hope you notice that one. We have the name of the function, and then we have the brackets towards the end. The name of that function, we have the bracket. So all the functions that we're going to define are actually having the parentheses to actually show us that this is actually a function. So in your program, anytime you say a name that is accompanied with some round brackets or what we call parentheses, you actually realize that this is actually a function. Therefore, it is performing a specific task in your program. Now, apart from building functions, in our lesson today, we are going to talk about user-defined functions. And we're going to see that these functions are first created by the programmers or data scientists to perform specific tasks. So let me give you a good example. You are a cyber security specialist and you want to encrypt data. So for you to encrypt data, you can actually define a function called data encryptor. And it will actually perform the specific task of encrypting information before transferring them from one point to another to improve their security, okay? So let's say you are a data scientist, you can actually define a function to transform your data, or to clean your data, or to transform data in time, or to provide counters, okay? So these are what we call user-defined function. And basically, this is what we want to learn today. And you're going to notice that for you to define your own user-defined function, we'll actually use a def keyword. There's a keyword we call def. This one stands for function definition. We are actually defining our user-defined function. So in more complex programming, you'll actually meet something we call a lambda function. Some people refer to them as anonymous function, okay? So this function, to just break them down in short, you can actually say that they are basically functions without a name. They are anonymous. Something without a name is anonymous. You can never identify it as a function. So a lambda function is basically a function that is defined without a name. So you're going to notice that anytime we define a function, we must provide a name, the specific name for that function. But in more advanced programming, you can actually create a lambda function and it will actually act as an anonymous function. And they are often used for short operation where a full definition is unnecessary. So there's some point whereby as you write your program, you just want to perform a very short operation. So therefore, there's no need for you to define the full function definition. So it's something that maybe we are going to see in our more advanced programming. And also, especially for those who will be doing the DSA, we've been talking about the design and data structures and algorithms. We'll meet something we call recursive functions. These are very important. So we can actually define a recursive function as a function that calls itself. Okay, at this point, it might not make sense, but in very, very advanced programming, we always use recursive functions. So for example, you have a scenario, build factorial calculation, you want to create a function to generate Fibonacci series, or even want to create a function that can perform tree traversal, then definitely at some point you will meet what we call recursive function. So by definition, a recursive function is a function that calls itself, okay? So what are the components of a function? So before even doing this function have their own components. So number one, especially when you're doing user-defined function, now we are here, not here, we are actually talking about user-defined function. So the first component is that there must be a function definition. So function definition means that you will first have to declare a function using the def keyword. That is something you're going to see, that before working with the user-defined function, then you'll have to perform function definition. Then after performing the function definition, we are going to talk about function call, okay? So function call is the situation now when you want to call a function that you already defined in your program. So how do you call it for it to execute? So it's actually executing a function by using its name followed by parentheses. So something to remember here about function call is that for you to call a function, then it has to be defined in your program, okay? We're going to talk about parameters, and we're going to notice that parameters are variables that accept values when a function it's called. They are actually like inputs that we feed into a function, similar to arguments. So you're going to differentiate what is the difference between a parameter and an argument. And then finally, the one very important component about a function is what we call the return statement. Because the return statement specifies the output of a function. So I want you to imagine you're providing inputs to a function. If you don't provide the return statement, then the function can never provide the output. So the output will always be none or zero, okay? Yeah, so later we'll be talking about different types of argument. I don't want to dwell much on them. We'll be talking about positional argument, keyword arguments, call arguments, variable length arguments, and so on and so forth. So it's something you're going to see in our programs. So let's just leave them at this point, and then we talk about the use cases of function. Now, why are we learning functions today? Why are they really important for any programming that you do? So number one is that function provides code reusability. That is important, you're going to see. And I've even given you an example. You have a function to calculate area of different shapes without rewriting the logic, okay? We're going to use function for our data processing and data analysis. Okay, later we'll be using function for mathematical and statistical operations in our data science projects. So at some point, you're going to use function to handle user inputs, okay? We are going to use function to automate repetitive tasks. Like you want to send an email, you don't have to write that code again. Just define a function for sending emails, and then you'll be actually performing function calls, okay? We'll be using function. This is actually for those people who are doing web development or they are doing software engineering. You're going to notice that they're actually using functions to build something we call APIs, application programming interfaces, in their web application, okay? So if you're actually a software engineer, then I think you've interacted with this kind of APIs, And in Python, you can actually use frameworks like Flask and Django to define your APIs. This is actually one area where you can apply function. And in this class, you're going to learn about machine learning and artificial intelligence. And you're going to see that functions are widely used in AI and machine learning for purposes like feature engineering. We're going to define them. Whenever you want to train a model, whenever you want to train a machine learning model, you want to evaluate a machine learning model, we will definitely need a function. For those people actually focused on cybersecurity, you can actually define a function to analyze the user logs. You can actually use a function to detect anomalies, and you can also use function to enhance software security, game development, and so many other application areas. So let's actually have our summary. So you can say that in summary, before actually now doing the practice, we can actually say that functions enhance code readability. That is number one. Number two, please always remember this one. If you define a function, use descriptive names. It's just like variables. Just work with a descriptive name. So if let's say you have a function, you want to build a function to scan networks, then you can actually call it network scanner. Just work with a descriptive name. This will actually improve your code readability and code maintainability. Then you're also going to see that if you properly use the return statement, we are going to have better data flow because function will be having outputs that we can use in other operations. Then this is actually more advanced, and I think we'll not do it here, but it's normally done on the DSA part, whereby we say that the recursive function should always have the best case. This is actually more advanced. And then we can also talk about modularizing code using function prevents debugging, improves debugging and scalability. So debugging is actually the process where you're trying to identify an error within your program. So if you have a function in your code, then it is actually going to improve that process, and it will actually make your software more scalable, okay? Those are very important detailed notes that I had for you. I hope at least by now you have an idea of what is a function and why we need functions in our programs. So if that is the case, I want us to go try out some practices so that we are now confident that we can work with functions in our software or data science applications. So now we can actually proceed right here. Unless there is a question, I wish to start with the code practices. So they are actually even telling us that so far so good. We've been dealing with many built-in functions. I want to talk about this one here. So we've been told that so far so good. We've been dealing with so many built-in functions. So this is actually how I define my built-in functions. I normally refer to them as functions. They are actually functions that doesn't need. So when you have a function that let's say a function that are already existing in our programs for specific built-in operations. So you have functions that are already existing for specific built-in operations. So therefore, you don't need to define them. So that is actually something to note. So NB, we can actually say that built-in function does not require. So with the built-in function, we don't need their function definition. Why don't we need their function definition? It's because they are already existing. They are actually built in. A good example of this function that we've been using is, for example, if you want to display data, so there is a building function that we've been using so far so good called the print function. This function, whenever you call it, without defining it, it will actually display information back to the user. I can even demonstrate. I hope this one you've already interacted with this for some time. Let's say I want to display something like data science and data analytics. So I just wanted to display that text called data science or data analytics. So long as I want to display any information, I will always call the print function, okay? So what I want you to remember about print function is that if you want to display text, they should be inside these quotation marks. If you want to display numbers, let's say I want to display the year 2025. If you are displaying numbers, then this is something we said we don't need the quotation mark. So this is actually a function whenever you want to display information back to the user. So let me even try another function that maybe we've not interacted with for some time. Number 2, there is another function that we use whenever we want to request data, whenever we want to request data from the user. So there is a function that is specifically designed to request information from the user. So what you'll have to remember about this one is that NB, if you use the function itself, we called it the input function. And this input function have a parameter, the one we call parameter. So the parameter that you pass to an input function or an argument that you're going to define later, it is here you pass the instruction. The instruction, okay? Just pass the instruction. Which type of data do you want? For example, let me even demonstrate here so that now we clearly understand what are these functions. So if you want to define, let's say you want to define the user name. So remember, the username is a string. We've already done data type. So we know that your username will be made of text, but not numbers. So because of that reason, you'll have to enclose it inside. You will have to define it inside the string function, and then you pass the instruction, like this one here. So this is at this point, I am actually requesting for your use, and I'm ensuring that it is a string, okay? Alternatively, let's say I want to get your age, I can even say the user age. And because we've already done some data types, we know that an age is an integer data type. So we'll have to say that I'm requesting for an integer. And this integer, for me to request it from the user, I will have to call the input function and provide the instructions as arguments. So if I run this through, you're going to see that it is actually now requesting for information. Like this instruction is saying, enter your name. So let's say I'm Eric, press enter. You'll have to press enter for this information to be stored in this variable here. So you just have to press enter when you're here. Now your name is Eric. I've captured your name as Eric. I hope you've seen that one. Your name has been captured as Eric. How about your age? Let's say I am 35 years of age. So my age will be captured as 35. So this is also a built-in function that is specifically designed to request information from the user. I hope that one is okay. So we have so many other ones. I don't want to use them here. So we've been told a good example of this function is something like the type function. There is a function called the len function, and so many other ones you're going to meet. Another one is something like, which other one do we use? It's something like the list, whenever you want to ensure something is a list, range, and so many other ones. I want you to note this one in your notebook. And always remember, if you're learning function, there are those functions that are built in, so they don't need function definition. So any question from there, you can try out those ones in case you get a challenge. Just pass the challenge on the chat. Yes, don't have an error. So what's the error saying? So what's the issue? Before now we go to the user-defined functions. That is actually our main business today. So I hope you, okay. So this should have been a comment. This should be a comment. I don't know, let me just copy it. Okay, let me just first copy it. Paste it here. See what's the challenge. Here. So this is your code. So remember, this is not a symbol that the computer recognizes. So remember, you have a variable and you have an information that you're requesting for here. So therefore, to assign this information to this variable here, we say that you use an equal sign. Okay, that is actually the symbol. It is actually what we call the assignment operator. It is used to assign information that you are requesting from the user to be stored in this variable here. So I hope that is the challenge you're getting. Now, if you run this program, you're good to go. Your name is John. Now, so you're okay. So remember all the time, when you have information and you have a variable, then we connect them with that equal sign. So that is okay. Okay, so let's proceed now to user-defined functions. Let's go there. That is our main objective for today. Yeah, you're welcome. So let's go here. So now, that is what we've been told, that we've already worked with so many built-in functions. For this section, we will focus with what we call custom function or user-defined function. So what is a function before we start making functions? So let's first learn them, then now we define them. So this is something we've already done. We'll say that a function is a reusable block of code designed to perform a specific task. Okay? Define or declare a function, we're going to see that Python uses the define keyword, and then the following syntax is what we use. What does it say? Yeah. So now we want to start. So if you now already understand what is a function, let's start by declaring a user-defined function. Let's go there now. So now we are in user-defined function. So this is okay. I have this okay. So this was number one. Then we then call it a built-in functions. So now we are talking about B. Now let's go to B. Now we are talking about user-defined. I think in that article, they call them customized. Custom functions, yeah. So one characteristic you've noticed about them is that, let's say that, before we even now deal with them, we can say that these functions first have to be defined. So this function first have to be defined, then later called when we want to so when we want to execute them. So I hope that one is now okay with you, that there is a user-defined function. Because they are not built yet, you will first have to define them, and then later you can call them. That's why in that topic, they've labeled declaring. So to declare is to define, and calling a function. So we're being told here that, When we make a function, we call it declaring a function. In other words, we call it defining a function. Okay? When we start to use it, we call it calling, or sometimes we say invoking a function. So you want to call that function to execute. You say now you are invoking that specific function. So you're going to see later that you can actually declare or define a function with or without parameters. So you can have a function that doesn't require any inputs, okay? But some function requires inputs that we're going to call them parameters. So this is actually the syntax. This is actually the syntax. Let's keep in mind about the function definition. It is a syntax. So the syntax is how do you do that one in Python? So to declare a function in Python, let's keep that one in mind. The first thing we'll have to do is use the keyword def, like we've been using. So this is what it say, like I am defining, then provide that name, the name of the function. So you can even call it password encryptor, network scanner, data cleaner. So the name of that function, and you have said that the name should be descriptive enough to actually describe the type of operation the function will do, okay? So you start with the keyword define, def, provide the name, and because we have noticed that all these functions have parentheses, you'll have to provide the bracket. So if you don't provide the bracket, then we'll not recognize that one as a function because all the functions that we deal with have this parentheses. So if you define the name, don't forget the bracket. Then finally, to end function definition, make sure you provide the full colon here. Sorry. So make sure you provide the full colon here. So this full colon that you see towards the end, it's very important to show us that this is the end of our function definition. So if you don't provide that full colon, then you've not clearly shown us where your function definition ends. So after defining a function, now the operation that the function is supposed to do is what we do in an indentation. I hope you've seen there is an indentation. So later we're going to call it a function body, what the function does. If you want to do encryption, you want to do scanning, and so on and so forth, you'll have to actually indent them inside what we call the function body. So this is what we call the function body. So here we'll actually put the codes for this function to do. And now for you to call a function, which is also very important to note, is that you will first exit. I hope you're seeing that. You will first exit the function body. You go back to the normal indentation, you will have to exit back, and then you call the function by the name that you use to define it. So if you use this name, that is the name that you call it here, and then you don't forget the brackets to say that this is actually a function. So I hope it makes sense. Let me repeat again. Def keyword, we are defining this function name. This bracket shows that this is a function, and then this full colon suggests that this is the end of the function definition. Now the implementation of that function, we put it as a function body, and I hope you're noticing that it has to be indented inside the function. It has to be indented. If you don't indent it, then it's not the function body. And now for you to call a function, again, I've said you'll have to refer to the name. That's why we say the name must be descriptive. So you refer to this name here, and then you put a bracket here, keeping in mind that you first exit. So to exit is to go back to the normal indentation. You'll have to go back here. So let's try this one. Let's start with defining a function without parameter. Okay? Let's start by defining a function without parameter. So I want you to copy this code here. Okay, let's just do it together. I'll do this one to try out. So I have a function that would generate my full name. That is actually the name. If you call this function, get my full name. Okay, so let's try it out here together. I don't want to copy that one. So defining functions without parameters. So let's try this one together. So let's define. Yes, there's a good question from John. You're asking whether there is a space between the bracket and the colon. There is no space. Yes, that's a good observation. There is no space here. Okay, even this space is not necessary here. Okay, even this space is not necessary here. So let's try it out and see how it goes. Let's see how it goes. So we can actually now define. So I want to define. So we say that is a keyword. So it is special work is to now define a user-defined function. You'll have to start with def keyword. And please remember, def keyword should not have an indentation like that one, okay? It has to start here. So that is the first thing you do. So after having the def keyword, you put a space, and now let's provide the name of this function. So for example, this one I can call it generate. This function, if you call it, it will generate my full name. That is the name. So we actually, okay. So we have actually had the def keyword. This is a function name. Please remember we say that anytime you define a function name, you must provide the brackets, because all functions we have the parentheses, the brackets there, okay? And now that is actually the name. So there's nothing else I need to do. So now let me end my function definition. Let me end my function definition. So I'll have to provide the full colon towards the end. So that one shows that I have defined a function called generate full name. And I hope you can see the function is actually as descriptive as possible. Now let's do that operation. So we say that the operation we normally have an indentation. So that is what we call the function body. You can even add a space if you want to. So how do you define your full name? You can create a variable called my first name is Eric. That is my first name. I think mine, Eric, has a K. What about my last name? So remember, we are still inside the function body. So you'll have to be inside the indentation. So my last name, is Otieno. That is my last name. And remember, in between my first name and my last name, there is a space. So I need to provide a space here. Let's provide a space. So there is a space in between my first name and my last name. So it is actually a string that we just include space. So this is actually my full name. So my full name, let me even follow this one, is that. So my full name is allowed to concatenate. So to concatenate is to join the first name with the space, the last name. So let's do that one here. Let's do that one here. So we can now say that my full name is, I will combine my first name, then I will first combine it with the space so that I have the space between. Then I combine it with my last name, like that one. So now finally, for this function to work, I will have to display. So if I don't display that name, the user will never see my full name. So I'll have to call another inbuilt function that we labeled the print function. And now we can actually put here our full underscore name. So this is what we call function definition. So we have three components. We have the def keyword, we have the function name, and then we have the function body. So I hope you're there. I can share this one with you in case you get a challenge, but please make sure to customize it with your own name. Okay, so I'm sharing this one right away in the chat. That one. So we have actually defined a function. I hope you're seeing that we have to start with the defined keyword, provide the name, we provide the brackets, we end the function definition with a full colon, and then this is what we call the function body, which normally has the implementation for that function, the specific task that that function is executing. Now, how about calling a function? How about calling a function? How about calling a function? So if I run this program, it will not execute. You see, I'm not seeing anything. It will not execute. It will not execute. So for this function now to execute, I will have to call it. So I'll just call it just like the print function. So what I need to do, I think I'll have to go back. So please remember you exit the function body. So now we say calling a defined function. So calling a defined function. So this is something to note and read. And it's a very common mistake that most people do. Make sure you exit the function body. Okay, make sure you exit the function body. So to exit the function body, normally the function body, it is here. So if I want to exit the function body, I will have to go back to the original indentation. Now I'm outside the function body. So if you're there, like the notes was suggesting, just refer to the name that you defined here. You refer to the exact name you defined here. We called it generate, generate full name, not full stop. What is it? Generate full name. And then, because this generate full name is not, it's not just a name, but it's a function, I will have to put the brackets. So this is basically how we call a user find function. We first exit the body, and then we put the bracket. Now, if I run this program, you're going to notice that it's actually generating my full name as Eric Otieno. So now I can share these are modules. We'll talk about them later, not now. I hope you should not confuse you there. So now I'll share everything now with you. I hope you can now try it out. And now I'm ready for any question up to there. I'm ready for any question up to there. I've mentioned what is a function. I've said we have an inbuilt function and a user-defined function. So we've said that inbuilt function, we don't need to define them. They're already there, so you don't need to define it. But anytime you are interacting with a user-defined function, then you first define it in this order. And then in case you want to call it, you can now call it in this order. Okay? So most people actually forget and call this function here. Let me tell you the common mistake that most people do. This is the most common mistake that most people do. You call your function here. So it's like you are now calling it inside the body. So it will never execute. Let me show you that one. It will never execute. Nothing would happen because you are actually calling that function inside its own body. So for you to call the function to execute successfully, okay, you will have to make sure you've exited the function body and then you call it like that one. Then if you run, now you're getting your implementation. So John, if it's not okay, then you can paste the code there. So I'm going to explain return later. I'm going to explain return later. I'm going to explain the return later. Yeah. Sorry there, I think I had lost my audio. So, yeah, sorry there. Now I hope you can hear me now. So I lost my sound. Yeah, so Martin, you have a very good question. What is the difference between print and return? And we're going to clarify that one in a short while. So John, you have an issue. Let's see your issue. So I just paste your code in my column here. Let's see what's the issue. Name, space. Yeah, so it's the same scenario I was talking about. If you want to call your function here, then you'll have to exit the function body. Remember, you'll have to exit the function body. So this function, you've called it inside the function body. So it will not execute. It will not execute. It will definitely not execute because you've actually called it inside the function body. So for it to execute, you'll have to actually call it here, like that one. So you have to go back to the normal indentation here. I hope now majority are observing that for you to call a function, you first need to exit the function body and then call it in a normal indentation. So if you now run this is actually verified. I hope you can see now that now it is executed. So make sure you call it outside the function body. So I hope that one is okay. John, now that one is okay. You've actually rectified that one. So let's proceed. Now let's proceed. Let's proceed. Yeah, let's proceed. So can you hear me? Yeah, so they're running now. I've not got any there. So the only challenge was here that you never exited the function body. So that is something to remember. And B, you first exit the function body and then have your function call. So to proceed, because now we have a lot to cover, maybe you can also try this one. Maybe you can now even copy this one. I hope now this one even makes sense. If you copy this one, if you paste this one in your program here, if you paste it here, I hope you can see that if you want to have a function, so I normally don't like this space here. I normally like to avoid it, but it do not change anything for now. So we are now saying that if you want to define a function to add two numbers, then just call the function, I want to add two numbers. So that is a very descriptive name. And that the add two numbers is actually a function. So therefore, you are actually providing the brackets. And then towards the end of the bracket, you're providing the full colon to make sure that you've actually ended your function definition. So in case now you want to add number one and number two, and you get your total, and then you print your total. So if in case you want to call it, as I've been repeating that one again and again, you'll first exit the body. So this is where the body is. I hope you can see where my cursor is. So this is what you call the function body. So you'll have to first exit that one. You go back here, and then you call your function name. So if you run this one, it's also working. That's 2 plus 3. You have a function that returns. So it's not returning yet, just like Martin have observed, it's not returning yet, but we're going to demonstrate that one as we proceed. So I hope that one is okay. I wish to share this one with anyone. In case you get a challenge, you can always refer to this code here. That one. Sorry. Yeah, like that one here. So I've actually now provided that piece of code there. Where is it? Okay. Now from there, let's proceed. Now we are there where Martin, you had asked, why are we printing instead of returning? So these are very confusing aspects. Let me try as much as possible to make it so that now it can make sense to you. Okay. I would start first by demonstrating the problem that we need so that now we can understand why we need function with return statements. Let's go and understand why we need that one here, okay? Now let's understand them here. So now we can talk about, so I've actually have I have a repetition here, sorry. Yeah, so now I'm here. So functions with return statements. So this is very confusing. Please now be very concentrating on this part. So now you're talking about functions with return statements. So this is the note. This is something I want you to always remember. Any function that you define, so you say any function defined must have a return statement. If you don't have it, so I can even say otherwise, if you don't have a return statement, the function does not have an output. So this is something I want you to see, that if you define a function and forget to put a return statement, then that function will never have an output. This is something I want you to see. So let's say, for example, I have a function called generate full name. So this function didn't have a return statement. Just like Martin, you observed that one. So if I put it here, it is a function, okay? We've defined it very well, but we've not actually provided a return statement. So what if I want to use your name in another operation? I cannot do that one. Let me even show you that one. So I want to store your full name here. So I can say store underscore full underscore name as
Where's Eric gone, guys?
Hello. Sorry for that one. Can you hear me?
Yes, you're back.
Yeah, sorry. I was talking about the return statement. Yes, I was talking about the return statement, and I want to demonstrate why we need the return statement. So let's say you have a situation where you want to store your full name. You want to store your full name. So there is a function that is actually generating that full name. I hope you've seen that one here. And this function, in case it generates that full name, you want to store it here. So if I've stored the full name here, let me print the result here. Let me see what I get here. I want to run this one and see what you get. You'll be told that there is nothing that this function has returned. So it is actually none. It is actually none. I hope you can see that one. I even wish to share this one so that you can see this other end, that anytime you have actually defined a function and then the function doesn't have a return statement, you can actually not actually get an output of this function and use it in another operation. So for example, I want to generate your full name and store it here so that I can now use it in other applications. Okay, so I want to generate your full name, store it here, and use it in other applications. So if I just print, it will not actually make sense because I've just printed your name, but I've not returned it back to the user so that now we can now use it in other operations. So instead of just printing the name, which is not even advisable, as we can see, it's not advisable. I don't need to print your name here. I just need to return your full name. Let's see what if now we return your full name. Let's see what happens. So what this function does is that we have your full name returned. So in case you call this function, it will return back to us your full name. So let's now run this program. And now we are noticing that now we are getting your full name, because if you call this function generate full name here, it would actually return your full name that we can now use it in other operations. So it's always advisable that anytime you define a function, you must return the output so that the output can be used in other operations. So any question up to there? This is actually normally very confusing. It's normally very confusing for most people to understand why we need a function to return a value. Okay, so I can even demonstrate with the other one that we've done. Yeah, so John, if you get that syntax error, just paste it on the chat and then I will address it. On the other hand, all about the two numbers, I have a function that this function here adds two number, okay? So what if I want to say now that I have the result of adding two numbers. So I have the result after adding the two numbers. So I don't want to print the result. Okay, I don't want to print the result. Maybe I want to do some tax, maybe collection. I have your salary, I want to do tax deduction. So the result of this value, I can actually take it. I can even say now, so I can say print, I take the result, I add 5 again. Can you see? So let's see what this one will do. If you run this program, this will return an error because you're trying to add results to 5, but this is none. Nothing has been returned here. So in case now you want to take the result and add more operation to it, then this function should have returned the total. So it should have returned the total so that now we can take that total, return it as our result, then add 5. Now you should run this program here. You now get that. If I take 2 plus 3, the total is 5, so I return 5. So if I call this function here, it will return to us 5. Now I can take that 5 here and add some more operation, like I even add 5. So now I'm getting 10. I hope this one now makes sense. Let me check the issue with John again. So in case you're getting an issue, please don't hesitate to actually put it on the chat. So it is on here. See what is the issue. I can now paste it here. Yeah, so what is the problem here is there is some repetition. It should not be here, right here. Yeah. And this, yes, this is actually a very good comment. It's a very nice comment to say that you returned your full name. Your store name is, I think this is okay. I think there was some code that had repeated themselves. The other side. I think just remove, sorry. Just remove this code here. The last 4 lines had some issues. So the last 4 lines from here up to here, just do away with them because they are providing syntax errors. Okay. So I have to generate full name, the first name, the last name. So now I can now generate a full name, store it here, and display it back to the user. So I think now this one would work. It's now okay. Remove the last 4. Like, I think you've already done that one. So any other challenge that you're getting? Any other challenge? Any other challenge? I hope now the return statement makes sense to you, that anytime you define a function and you want your function to have an output, then definitely you have to provide a return statement right here. So let's see what my program, the note is actually saying. So the note was saying that function can also return values, which is even a must. So if a function does not have a return statement, the value of that function is none. The return value for that function is none. It's like you're saying nothing has been returned from that function. So we provided some inputs, we don't have an output. So let us even write the code above, and that is what we've done here. So I even wanted to demonstrate it in a better way, and I hope now it makes sense. Can we now go to functions with parameters? Let's talk about them in case there is no question there. Okay, allow me to talk about now functions with parameters. So if that is okay, now here we're talking about, so we're talking about functions with parameters. So we have some functions with parameters, and even add arguments. So before even going to the notes, you can actually define them here. We can say, number 1, what is a parameter? What is a parameter? So what is a parameter? So you can say that a parameter is a variable. So that is the keyword. That's why I'm putting it in capital. It's a variable passed inside the brackets while another keyword is while defining a function. So then you're being told that as you define a function here, you can put some variables here inside this bracket. And this is actually what we are calling parameters. So they are variables you pass inside the brackets while defining a function. On the other hand, number 2, what about an argument? So what about an argument? So an argument, it's a value, not a variable now, it's a value that is passed inside the bracket while, so now the other keyword is while calling a function. So those are the two differences. That is the difference between a parameter and an argument. So we are being told that a parameter is a variable that you will pass as you define a function. You'll pass a variable. Then an argument is basically a value that you pass as you call a function. So let's demonstrate this one, this outline here. So you're being told that in a function, we can pass different types of data like numbers, strings, booleans, lists, tuple, dictionary, and set. So we can put information, data types, inside them as parameters. So this is actually a single parameter function. So a single parameter function is basically a function that will only accept one input as parameter. So this is actually the example. If I'm declaring a function or I'm defining a function, def keyword, this is the function name. I will pass here what we call a parameter. So it's actually a variable that I will use to store data, and then proceed with my code implementations here. Now, an argument is actually a value that you pass as you call a function. So that is the difference. A parameter is actually a variable you pass as you define a function. An argument is a value you pass as you call function. So let's even have a nice example. This is very nice. I think this is very nice. This is nice. So we'll start with single parameter function. So a single parameter functions. So we have single parameter functions like this one here. So I have a function called greeting, normally like to avoid the space here, but it doesn't have any change. So now I'm saying I have defined a function called greetings. And for me to greet you, I want to greet you by your name. By your name. So the name that you provide later, I will actually store it in this variable called name. So you give me your name, I will store it here. So where I will store your name is what we call the parameter. It's a variable. So it's a variable that we use to store some data. I want to greet you by your name, so give me your name, then I will store it here. So now the message will be, this name that you've given me here, remember you've given me your name, so I'll actually say the name that you've given me, I will add, welcome to Python for, and I will say Python for data science. Okay? So I'll say, like, let's say you give me your name, Anthony, so I'll tell you, Anthony, welcome to Python for data science. You say your name is Jane, then I'll say, Jane, welcome to Python for data science. So it's actually a variable that is used to store data. It is used to store data. So if I want to greet you now, see how we've done this one. I just have to print. So I want to display the greetings. I'll just say I want to display. And then I call the greetings function. And then this greeting, it's a function. So remember, we are declaring it with a parameter. So it has a parameter here. It has a parameter here. Because it has a parameter here, why should we call it without an argument? Because remember, we are actually expecting a value. So the value that we're expecting here is now what we are calling an argument. So an argument is basically a value that you pass inside the bracket as you call a function. So I'm calling the function greetings. Now is your name. Because if I even run this code, I will have to get an error because you're being told here that this function called greeting is missing one positional argument. So we need an argument that we can store in this variable name. So let's say if you say your name is Derek. Now we are good. So you've given me your name, Derek. I will take this name and use it as my value here. So if you run this one, now the program will say, Derek, welcome to Python for data science. Let's say you have someone else like Anne. So if you run this one, then it actually say, Anne, welcome to Python for data science. You say your name is Lucy. Then the program says that now, Lucy, welcome to Python for data science. And I hope you can now see that with these parameters and arguments, your code is now reusable. Lucy can use the program because whenever we are now working with Lucy, I will actually refer to Lucy. I can also use the program. So Eric, I can also use the program because now the program will be referring to me. Okay, so now the program becomes reusable. I hope you actually went to an ATM machine to withdraw some cash. When you insert the card to the ATM machine, the system greets you by the name because there is a function that has captured your name and it is being reused to display your information. Okay, so I want to try this one out. Get an issue. Don't hesitate to ask on the chat. Where is it? So we are still here. So this is actually a single parameter value. So let's say I want to take a number and add 10. I want to take a number. I want to take a number. I want to take a number. So I want to request a number and add 10. So what I should do, I should first define a function called add 10. Then you'll provide me the number. Okay. Then you'll provide me the number. So I don't even have to say 10 here. I can even make it shorter. I can say that if you give me the number, I will take that number and add 10. I hope you can see that one there now. So there's a function called add 10. So this function, if you call it, you'll probably give me a number, then I'll add 10. It's like you want to give someone a discount, or you want to calculate, you want to do some deduction. So let me print this one here again. So I'll have to exit. Then I print. So if I call a number, then I add 10. In this 10, the answer should be 20. If I have 15, I had 10, the answer should be 25. So it's actually a function that we just take any value, then we add 10. So I'm also sharing that one for more elaborations. In case you're getting now challenges, please feel free to pass them on the chat session. So moving further, so far so good, no question. There is even a function that it will accept a number, then it will return the square of that number. So it's even nice to explain. So it is a function that you give it a number, then it returns the square. So it returns the square of a number. So this is actually how you can implement that function. So it's actually a function that maybe you can call that number x. So now I just call it x. So this function called square number, you'll actually now provide x and then return the square of that x. So for example, if we have 2, the square of 2 is 4. If I have 9, the square of 9 is 81. So I'm returning the square of that number. So I have a challenge from John. So let me provide this one so that now you can also try out. And now in case you're getting any challenge, please feel free to place it on the chat. So I have this one here. Let me see what's the problem. That one. I can now paste it here. Name. Yeah, so actually you've repeated the same mistake again. This print function should have been here. You'll have to exit. Then this name that is called, this is actually a text. So remember, it has to be inside quotation marks like that. It is actually a text. This name is not a number, it is a text. So if I want to greet you by your name, then I'll have to pass it as a string. So now if you run this code here, I think now you're good. Okay. I hope you can see that one. So we have this name here. Okay. So let me now share with you back. So please always keep in mind, if you want to call a function, then you first need to exit the function body. I hope I'm saying that one. You need to exit the function body. So let me share this one with you here again. So anyone else with a challenge? Anyone else with a challenge? Anyone else with a challenge? Anyone else with a challenge?
Excuse me, sir.
Yes.
Excuse me, sir.
Yeah.
When doing the return statement, are we returning the, what are we returning, the parameter or what we have defined? Like, for example, with the defined square number, uh,
Yes.
I, I want to understand what are we really returning, sir?
Yeah, that's a good question. That's a very good question. So to return, yeah, so to answer your question, you said, what are we really returning? So that's a very good question to ask. We said that the return is actually, we are actually returning the output of our operation. Okay. For example, here, I can define a function to return to someone the area of a circle. So I want to define a function that if you call this function, what we are actually returning is the output, the whole output of that operation. Okay. So this man, I hope you can see here that for you to get an area of a circle, let's first remove this one. If you want to get an area of a circle, you will provide the radius. So we are not returning the radius. We are not returning the radius. We are returning the result of the whole operation. I will take pi as 3.142. Then the area is pi, you multiply by radius square. Okay, radius square. Okay. So what I'm actually returning to you is actually the area, not the radius. So the radius is a parameter that will allow me to calculate the area. Like for example, this one, this value that I provide here is a parameter that will allow me to return the square. So definitely what we are returning is the result of the whole operation. So I hope it's making sense that, for example, I have the area of a circle. If you give me the radius, I am going to return the area for that circle. Okay. I think this one looks very confusing. So you can just say R times R, pi R squared. I think that is the formula, pi R squared. Pi R squared. So the area is actually pi R squared. So I can even say here that the answer is, I just need to call the area. So the answer when the radius is 7, it's actually, I just need to call the area of a circle when my radius is 7. I hope you can see that one here. So the answer when the radius is 7 is that call the area of a circle, put 7 as your radius. So if you run this one, now the answer is 153. But now you might have another scenario whereby you want the answer when the radius is 14. When the radius is 14, so what you need to do, call put the area of that circle, place 14 here as the radius, then you're going to get your answer as 615. Maybe probably you want to return the area of the answer when the radius is, let's say, 28. 28. So to do that one, you're going to call the area of that circle. You put the radius as 28. Then what I'm returning is the answer. If you give me the radius as 28, the answer is 2461. I hope it's now okay. I hope it's now making sense that we are returning the output of the operation. So this is actually just a parameter that you provide so that you get the answer. Another parameter, you can even use another parameter, you get your answer here. Another parameter, you can get your answer here. And in that order. I hope I've answered that question. I hope I've answered that question for you.
Yeah.
Okay. Okay. So from there, we can now talk about, let me see. So far we talked about defining a function. We talked about calling a function. We've talked about parameters. We've talked about arguments. So let's see then what else do we have? So we can also have two parameter function. So we can also have a two parameter function in such a way that this function can accept two parameters. So for example here, where's the two parameter function? So a good example, I want to greet you with both your first name and your last name. So I hope this one would even make much more sense to you. If I now, let's wait here. So there should be some indentation issues that was there. So that's okay now. So your first name, your last name. So let's say my first name is Eric. My last name is that one. So if you want to get to greet you with both your first name and your last name, then this is basically a two parameter function. So because we have two parameters, you will need to pass two arguments. This argument will be stored on this parameter, and this other argument will be stored on this parameter. So if you run this code, then I hope you're noticing that this is actually a two parameter function. This is actually a two parameter function. So it will accept more than one parameter. As continue, you can provide three parameter function, four parameter function, and so on and so forth. So still proceeding with function, there's no question up to there. Let's say you want to have the sum of two numbers, so you can have the number one, number two, you get the sum of these two numbers. So I think this is even better. I can even build a function. To return, if I press it here, to return the age. So it returns the age of a person by accepting the current year. So it accepts the current year and the birth year. So this good example, you're saying that I want to calculate your age. So give me the current year and give me your birth year. So to get your age, allow to take your current year, I subtract your birth year, then I'll return your age. So in this example, let's say I was born in 2000, and currently we are in 2025. How old am I? So if someone was born in 2000, then it's 25 years of age. So if I was born in 1991, then currently I am 34 years of age. Okay. So the good thing with the parameters and argument is that it allows you to actually make your code reusable. So you can even say And even say, if someone was born in 1995, 1991, you are actually 34 years. If you are born in 1995, currently you are 30. If you are born in 2000, currently you're 25 years, and so on and so forth. So this is actually a two-parameter function. It's actually a two-parameter function. So any question up to there? Any question up to there? So if you move further now with function, which I want to now to, this one maybe you can now research on your own free time. You're going to notice that we also have parameters with key value. So you can actually have a parameter with key value in such a way that if you declare a function, and this is the first parameter, this is the next parameter, and you call a function, you can actually put the key, then you place the value. Key, then you place the value. So it's what we call parameter with key and value. So a good example, I can actually use this one here. I can actually say that the current year is 2025. The birth year, is 1994. So if I run this code, I'm also going to get the same output, but the arguments that I'm passing the key, I assign it a value. I press the key, I assign it the value. And this is what we call parameter with key and value. So parameter with key and value. So let me share that one with you. So you can also notice that as you place the data, you can always refer to the variable names. And also, you can always refer to the variable names. So moving further, there are a lot to do here. So from parameter with key and value, these are actually arguments, not parameters, arguments. These are actually arguments with key and value. So you have this argument where you pass the key, the current year was the key, the value is 25, and so on and so forth. So moving further, you can also talk about function returning a value. I think we've seen that one. Function returning a value, you've seen that one here. You can return a number, you can return a Boolean. So you can return even a Boolean, for example. So as you return a value, there are different types of value you can return. You can return strings, you can return integers, you can return Booleans, so long as it's a value. And then now we also have functions with default parameters. So if you define them, you're actually going to provide some default parameter like this one here. I have defined a function called greeting, but the default name is Peter. So if you don't provide the value, then it will actually call Peter. But if you provide the value, then it's going to use the value that you've actually provided right here. And then finally, now we have the arbitrary arguments, default arguments, and so on and so forth. So I think definitely that will now mark the end of our functions. So I would wish we have one more class. We talk about modules and OOP. So I think in our next class, because of time, I thought we'd have done them today, but in our next class, let's talk about modules and object-oriented programming. So here then, would have actually now highlighted all the main aspects of Python programming, and now we are ready to use it in our data science classes. So any question up to there? Any question up to there? Okay, so if there is no any question, I want to share this notebook with you. I want to ensure it can be used by anyone. Then I can pass it on the chat here. And now anyone is allowed to use the notebook in case now you want to do your own more practices. I wish you a good day. So let's meet our next class on Monday. We first introduce Python modules and OOP so that now we are ready to start data science or data analytics using Python programming. So have a nice day. Bye-bye.